Good afternoon, sir. Myself B. Rajeshwari. I am pursuing second BTech in SRIT. Here my topic is numerical problems on Nyquist plot, subject control systems. Problem on the Nyquist plot. Draw the Nyquist plot from the systems whose open loop transfer functions g of s is equals to s of h, k by s into s plus 2 into s plus 10, determining the range of k for which closed loop system is stable. Given g of s into h of s is equals to k by s into s plus 2 into s plus 10 equals to, converting into s plus 1 form. Finally, the equation be the 0.05 k by s into 1 plus 0.5 s into 1 plus 0.1 s. In the open loop transfer function, a pole at the origin, hence the Nyquist counter of a S-plane enclosing the entire right plane expecting the origin. The Nyquist counter, the four sections are there: C1, C2 and C3 and C4. The equations of each section is performingly separately and the overall plot obtaining by the combination of the individual plots. Now we need to draw individual plots of the C1, C2, C3 and C4. Finally, we adding both the C1, C2 and C3 and C4. Finally, the Nyquist plot we will get. Mapping of section C1. In this section C1, we varies into W is equals to 0 to plus infinity. Mapping of section 2, G of j omega into h of j omega varies from 0 to infinity. Earlier we know that g of s is equals to h of s, 0.05 k by s into 1 plus 0.5 s into 1 plus 0.1 s in the s plus 1 form. Let convert into s is equals to j omega. G of j omega into h of j omega equals to 0.05 k by j omega of 1 plus j 0.5 omega into 1 plus j 0. Omega. Finally, the equation be the 0.05 k by minus 0.6 omega square plus j omega of 1 plus 1 minus 0.05 omega square. The mapping Nyquist counter of a S-plane is the first we need to draw the C1, C2, C3 and C4, find the contours, and again we will modify omega equals to 0 in the origin, omega is equals to plus infinity, and downward omega is equals to minus infinity. When the locus of a g of j omega and h of j omega crosses real axis into imaginary terms, the imaginary terms frequency of the omega is omega pc. At omega is equals to omega pc is equals to 1 minus 0.5 omega square pc is equals to 0. Omega pc is equals to root of 1 by 0.05 is equals to 4.472 radians. That is the omega. Finally, the equation is the g of j omega and h of j omega equals to 0.05 k by 0.6 omega square. The omega square we know earlier 4.47 is the value. Substitute in that we will get minus 0.00417 k. Mapping of S1 plane. The sections of the S1 we will draw the S-plane. Again we draw the mappings. In the mapping there is we will find 0.00417 k. Again we will draw that mapping. Mapping of section C2. The mapping of section C2 from S-plane G of S into H of S plane obtaining by the letting S is equals to LT r infinity to r to infinity r e to the power of j theta. G of s into h of s in s plus 1 form, we know that 0.05 k by s of 1 plus 0.5 s 1 plus 0.1 s k by s cube. Let s into lt r tends to infinity r is e j to the power of theta. The equation we get finally to the pi by 2 and minus pi by 2. G of s is equals to h of s 0 e to the power of j3 pi by 2 plus j3 pi by 2. These mappings of this is a section of C2 and again we will draw mappings. Here C2 is a r tends to infinity, j omega in the up direction. We will mapping the g of s into h of s plane. Jv is equals to omega. Mapping of C3 in sessions C3 omega varies from minus infinity to 0. The mapping of section 3 C3 is given the locus g of s into h of j omega, and omega is varies from minus infinity to 0. The inverse polar plot. This is the inverse polar plot. C1 is the normal polar plot. Here inverse polar plot g of j omega into h of j omega. The inverse polar plot is given by the mirror images of the polar plot with respect to real axis. This is a section C3 in S-spline. Omega is equals to 0, omega is equals to minus infinity. Upward direction j omega. This is a reverse plot. We will find the 0.00417 k. We will draw the mapping of the Nyquist plot. Mapping of C4. The mapping of C4 from the S-plane of the G of S into H of S plane lettings to the S into SLT R tends to 0. R is J omega. From here we know the earlier equations of 0.05 k. S into plus 1 plus 1 plus 0.5 s 1 plus 0.1 s. This equals to 0.05 k by s. Let s is equals to LT R tends to infinity R e to the power of j theta. Finally, we got theta is equals to minus pi by 2. There is the equation infinity e to the power of plus j by square. Infinity theta is equals to pi by 2. G of s into h of s equals to infinity e minus j pi square. Finally, the mapping of the C4. The C4 is equals to R tends to infinity in the downward direction minus side. This is the section of C4. This is the mapping of C4 of GS, G of S into H of S. Complete Nyquist plot. The entire Nyquist plot of the G of S and H of S. We obtaining the both C1, C2 and C3, C4. All these contours we will draw in the one plot. That is the final Nyquist plot. This is the final Nyquist plot of the G of S into H of S plane, and a contour R tends to infinity and R tends to 0. This is a stability analysis. Stability analysis minus 0.04117 k is equals to minus 1. The limiting value of k is equals to 1 by the equation of omega. We will substitute that 0.00417. It is final equation of the 240. The stability analysis is the 240. When k is equal k greater than 240. When k less than 240, the contour crosses of a real axis of point 0, 0 and minus 1 plus j0. Through the Nyquist plot along the indicating directions, the minus 1 plus j0 is not encircled. This no poles of the open loop transfer functions. There is a closed loop system is stable. This is k is less than 240, any number, it's a stable. K is less than that greater than that number, it will be unstable. When k greater than 240, when k is the greater than 240 of the contour crosses real axes at the point between minus 1 plus j theta, traveling through the Nyquist plot along the indicated directions is the found of the points. Minus 1 plus j theta is the enclosed clockwise direction 2 times. Since there is a 2 clockwise in circles of the no right half plane half poles, the closed loop transfer functions 2 poles on the right half plane and transferring in the closed loop unstable. Final result is that the value of k from k for stability 0 less than k less than 240. Thank you.